Welcome to Math 1300, Nunez Community College. Today's section is section 4.5, which is the zeros of polynomial functions. Zeros of the functions is where it crosses the x-axis. This is important when it comes to graphing the polynomial functions. But what we have to do is we have to find the zeros. In earlier videos, we were given a 0 or 2 that we had to factor out, and then from there we would continue factoring until we got down to all of the zeros in the polynomial function. But if they don't give us a 0, how can we possibly figure that out? Well, there's something called the rational zero theorem. The rational zero theorem, it doesn't give us the exact answers, but it gives us the possible exact answers. It's up to us to then find what we need to find. So it says use the rational zero theorem to find all possible rational zeros if we have the function f of x is equal to x to the third plus 10x squared plus 2x minus 24, plus 2x minus 24. So the rational zero theorem allows us to find the possible rational zeros. So this is the possible rational zeros. And the rational zero, the possible rational zeros that we're going to find is going to be all factors of the last term being 24, over all factors of the first term. In this case, the first term is a 1. So all factors of the last term for 24, I have what? Plus and minus 1 and plus and minus 24. Because 24 times 1 is 24. Both the pluses and the minuses. I have plus or minus 2 and plus or minus 12. Plus or minus 3 and plus or minus 8. And then finally, since I don't have enough room, plus or minus 4 and plus or minus 6. That would be all of the factors that's on the top. On the bottom I have 1, so it's plus or minus 1. So these are my possible zeros, which would be 1, negative 1, 2, negative 2, 3, negative 3, 4 and the negative, 6 and the negative, 8 and the negative, 12, and 24. Now, this is a lot of possibilities, but if you think about it, in the grand scheme of things, this really narrows it down. This narrows it down to be way less than an infinite number. And what we have to do in order to find which one works is we would have to synthetically divide each one of the numbers by the polynomial, or divide the polynomial by each one of the numbers till we come up with a 0 remainder. Once we do, that would be one of the answers. You can start and do whatever one that you wanted to do first. So if you were eager and wanted to do 24 and synthetically divide that, you could, or if you wanted to start with 1, I would start with 1 and work my way as they get larger. Hopefully the 1s work. If not, hopefully the 2s work, but sometimes you may have to work all the way to the end before you can find it. But again, this is the rational zero theorem, which allows us to find the possible rational zeros. The possible. So let's look at another example, and we want to find the possible rational zeros of the function f of x is equal to 2x squared plus 5x plus 6. Well, at least it's a smaller number than 24 with not as many factors, so that's good. So remember, it's the factors of the last term, which is 6, so that's plus or minus 1, plus or minus 6, and then what, 2 and 3, so plus and minus 2 and plus or minus 3. That's the only factors we have of 6. Now we also, though, have a lead coefficient that we have to put up there. So 2 would be plus and minus 1, and plus or minus 2 would be the factors of 2. So all the possibles is going to be plus or minus 1 over 1, plus or minus 2 over 1, plus and minus 3 over 1, and plus and minus 6 over 1. But then you also have plus or minus 1 over 2, plus or minus, well, 2 over 2 we already have. It's 1, so I'm not going to include it. I'm not going to write it down twice. Plus or minus 3 over 2, and then plus or minus 6 over 2. But again, at 6 over 2, 6 over 2 is 3, so I'm not going to write it twice. So these would be my possible solutions to factoring this. My possible solutions to factoring this. This only gives me the rational zeros. So if the 0, or we're solving it, we'd have to use the quadratic formula and come up with the square root, then it would not give us an irrational number. It only is going to give us the rational zeros, or the possible rational zeros. So let's look at one. Example number 2. Find the zeros of the function. Find the zeros of the function. So I got f of x is equal to 2x to the third plus 3x squared minus 8x plus 3. Minus 8x plus 3. And we want to find the zeros. So in other words, we want to solve if this would be equal to 0. So I want to find the possible rational zeros. So that's going to be what? Plus and minus 1, plus and minus 3 over plus and minus 1, plus and minus 2. Factors of the last term over factors of the first term. So that's going to be what? 1 plus or minus 3 plus or minus 1/2 plus or minus, and 3/2 plus or minus. Well, I would prefer to deal with a 1 when synthetically dividing, and then a 3 before I have to deal with fractions. So let's look at the 1. So we'll see if 1 is a 0. Again, we're going to find out by synthetically dividing and finding out if we have a remainder. If we do have a remainder, then it's not going to work. If we don't have a remainder, then it is a factor. Which will give me 2, 3, -8, and 3, because again, it goes in descending order and we have each one. Now, once you're trying to do this and you find out it will have a remainder, then stop it and just go on to the next number. So I'm going to bring down a 2. That gives me a 2. This gives me a 5. I can see it's not going to work. That's going to give me a 5. Never mind, it might work. This will be -3, and therefore it gives me a -3. And in fact, it is a factor. It is a factor. So I know that 1 is a factor of this. So once I do, I now want to put it as, what do the factors look like having x's in it? This one, written as a binomial, will be x minus 1, the opposite. And this will be 2x squared plus 5x minus 3 equals 0. So what do we have here? We factored out the x minus 1 as a binomial because 1 is a 0. And this is what we're left with, which is the trinomial. So at this point, we will try to factor this. Because if we can factor this, then the 1 and whatever we have for our answers here will be the answers. Can I factor this? I think maybe so. That'll be a 2x and an x, and a 3 to give me a 5. That's going to be a 3 here and a 1 here. That will be on the outsides 6x, and on the inside 1x, and it's going to be positive and negative, so it's negative 1x to give me a 5x. That'll give me my middle term 5x. So I have this, x minus 1, and those two, which we just factored, 2x minus 1 and x plus 3. And now we have, these are our factors, which means they multiply together, and they're going to give me 0. Well, again, in order for it to be 0, either that one or this one has to be 0. One of them has to be 0. So x equals positive 1, or x equals 1/2, because again, I'm solving, or x equals negative 3. So my answers are going to be 1, 1/2, and negative 3. These are the answers that if I multiply them together, I would get the function, the polynomial function that's given. Okay, let's try one more. Remember what I said though. This is the possible, and look, we won, that worked. Through negative 3 worked. And 1/2 worked. So all the possibilities was in what we had. We just found the right ones that worked. But like I said, this only gives you the rational answers. It doesn't give you the irrational answers. So let's try another one. The next example, again, is going to ask us to find the zeros. It's going to say find all the zeros. And this time they're going to give us f of x is equal to x to the third plus 3x squared minus 3x minus 9. Okay? If I want to find the possibilities, well, it's going to be plus and minus 1 and plus and minus 9, factors of 9, and plus and minus 3, all over plus and minus 1. So basically it's 1, negative 1, 3, negative 3, and 9, negative 9. For purposes of time, I'm going to skip ahead to the one that actually works, and the one that works is going to be negative 3. So I would have tried 1 and negative 1, I'd have probably tried positive 3. So this would be what? 1, 3, negative 3, and negative 9. I would have brought down my 1, multiplied, giving me a negative 3, 0, 0, negative 3, positive 9 for a remainder of 0. So my binomial would be x plus 3, which accounts for this, and then I would have x squared, no x, so minus 3 equals 0. So since this is x squared, I have to get it as x, so I have to take the square root. So I have x squared minus 3 equals 0. Bring the 3 to the other side. Bring the 3 to the other side, if I don't write the right exponent. And then I'm going to take the square root, but when I use the square root method, it's both plus and minus the square root of 3. This now is my answers. Well, these are my answers. X equals negative 3, because that's the first one that we found, which was the one here. And then we have square root of 3 and negative square root of 3, both plus and minus. These are my answers, but if you can see, remember that these were not included because these are irrational answers, and this is only the rational zero theorem. All right, well, this concludes section 4.5. I'll see you at the next one.